As we get into calculus, one of the important things that we'll need to be able to do is analyze graphs. And we'll need to know key features. One of the things about key features is being able to find the intercepts of a graph. At the end of this lesson, you'll be able to find the x and y intercepts of a graph. All right, to find the intercepts of a graph are just the points at which the graph intersects the x or the y-axis. Probably pretty familiar with that. To find the x-intercepts, you're first of all going to let y equal 0. Then you'll solve the equation for x. And then you'll write the x-intercept as a point. Notice that the value will come first and then 0 will come after that. To find the y-intercepts, you're going to let x equal 0. You'll then solve the equation for y and write the intercept as the point 0, b. So let's do a few examples. Here we go. All right, in the first example, you'll notice that it says y squared equals x cubed minus 4x. First of all, let's get the y-intercept. And to do that, we're going to let the x value be 0. So we'll have y squared equals 0 cubed minus 4 times 0. And we just get 0 as an answer. And we still have y squared, but if we square rooted both sides, we would still get 0 as an answer. So when I write the y-intercept as a point, it will be 0, comma, 0. So this graph crosses the y-axis at the point 0, 0. To get the x-intercept, we are going to let the y value be 0. So we'll put 0 squared equals x cubed minus 4x. 0 squared is, of course, just 0. And then from here, I notice that I can factor the right side by factoring out an x. So I'm going to factor out an x. And when I do that, I get x times the quantity x squared minus 4. I then notice that x squared minus 4 is a difference of squares, so I'm going to continue factoring into x plus 2 times x minus 2. And then since the equation is set equal to 0, I'm going to use the zero product property, which you're just going to find where each expression of that problem would equal 0, and that will be at x equals 0, at x equals negative 2, and at x equals 2. So the x-intercepts of this problem are going to be 0, 0, negative 2, 0, and 2, 0. All right, next problem. Again, let's start with find where my little cursor is here. There we go. All right, oh goodness, to get the y-intercept, sorry, I'm just getting used to this here. We're going to let the x value be 0, so plug in a 0 wherever you see an x. And when we do that, you'll notice I'll get 0 in the numerator, I'll get 1 in the denominator, so that once again just equals 0. So our y-intercept is the point 0, 0. Okay, to get the x-intercept, we'll let the y value equal 0 this time. All right, let me just rewrite this here. Okay, I'm only going to be concerned about the numerator of the problem on this one. If the denominator were to equal 0, the problem would be undefined, so that's not something that I need to worry about right now. But if the numerator equals 0, then the problem would equal 0. So I'm going to set the numerator equal to 0. And then I notice that I can factor out an x, so I'll do that. So I'll get x times the quantity x plus 3 equals 0. And then again, applying the zero product property, I'll notice that that expression will equal 0 when x equals 0 or x equals negative 3. So my x-intercepts are 0, 0, and negative 3, 0. So we have now just found the x and y-intercepts of a graph.